Let the joint distribution of random variables x1, x2, x3 be normal mu1 sigma with mu1 sigma given. Now we need to find like which of the following statements is are true. So we have x1, x2, x3 follows this normal with mu1 sigma, and sigma is given as 1, 0 0.50, 0 0.510, 0, 0 and 5. So the key rule here is like any two linear combinations in jointly normal random variables. So two linear combinations are independent. So that means their covariance is 0. So if we consider this x1 minus x2, so if we consider the covariance for option A, so covariance of x1 minus x2 plus x3 comma x1, so that will just be covariance of x1 comma x1 minus covariance of x2 comma x1 plus covariance of x3 comma x1. So that will just be 1 minus 0 0.5 plus 0. So that is 0 0.5, which is not equal to 0. So therefore they are not independent. Similarly, the second option says x1 plus x2 comma x3 minus x1. So that means it is x1 x3, which is 0 minus, and then x1 x1, which is 1, plus we have x2 x3, which is 0 minus 0 0.5, which is not equals to 0, as this is nothing but minus 1.5, which is not equal to 0. So second option is also incorrect. Now if we consider the third option, we have like covariance of this x1 minus x2 plus x3 comma x1 plus x2. So if we consider the matrix again, the covariance matrix, so we can clearly see covariance of x1 comma x1 is 1, and then x1 comma, and then like we have x2 comma x1, so x2 comma x1 is 0 0.5 plus x3 comma x1 is 0 0.5 minus 1 plus 0. So that means this is nothing but 0. So therefore option C is the correct answer. Similarly, we can also check for option D. So if we quickly check like 2 and 2, so that is 2 into 1 minus, and then we have like so 2 into 0 0.5, and then we have minus 4 into 0 0.5, and then we have minus 2 into 1. So that means this is nothing but 2 minus 1 minus 2 minus 2, which is minus 3, which is not equal to 0. So therefore option C is the correct answer.